Hello everyone. So let's start solving today's Leetcode daily challenge question. So the question is minimize XOR. Given two positive integers num1 and num2, find the positive integer x such that x has same number of set bits as num2 and the value of x XOR num is minimal. And we have to find this x, okay? And we have to return that x and the test cases are generated such that x is uniquely determined, okay? So let's say this example num1 is 3 and num2 is 5. So what we are given is we have to find x, a number which which has the same number of set bits as num2 and the XOR with num1 should be minimal. So here you see the binary representation of num1 is 0011 and num2 is 0101. So we have to do what we want a x with same x or same set bits as num2. Okay, so two set bits we want, and the XOR with num1 should be minimal. So with XOR, let's say this x XOR num1 should be minimal, right? So why can't we consider num1 XOR num1, which will be 0, right? So we got a minimal. So this is the first possibility. So here you can see the set bits are same of this 2, and here also 2. Already in num1 there are 2 bits. So they are doing what? 3x or 3 is 0, which is minimal. Okay, but here instead of x we can use num1. But the other condition is same number of set bits with num2. So if num1 and num2 are with the same set bits, then of course it will be the same. But if not, okay, let's say we have in num1 we have three. Let's say we have this, and our num2 is okay. So how many set bits are there in num2? Are 4, and in num1 are 3. Okay, so we as we know num1 XOR num1 will be 0, okay, which is the minimum. So we will consider num1 and we will change the bits in it. So let's say here we have 4, so we want a x with the 4 set bits, right? So we can modify this number, this num1, to make to that means to build a x basically. So what we will do, we have to add one set bit, okay. And let's say if we have another case where our num1 is 1 0 1 1 1 0, or let's say 1. So how many are there? 5 are there. So we want 4, so we have to reduce one set. Okay, so we got these two cases. If I have more number of set bits in one, then I will reduce it. If less, then I will add it. Okay, to make a number which has same set bit as num2. Okay, so where we will add, from where we will delete, is we will see the least significant bit. So least significant means the rightmost. Okay, so this is the least significant bit. So we, if let's say here I have to add one set bit, that means I will check the last 0, okay, and I will just do the, let's say I will check what I will check to get which is the my first least significant, which is 0, is I will do this, let's say I will do this and I will get the answer. If I get the answer 0, that means this number is 0. If it was, I mean, in here we have to do the and operation. We will do the and operation, and we will check if my and with this number, okay, That means we will check with each index, right? For least significant. So for least significant I want a 0 to add 1. To here we will add, if I get this 0, okay, this and operation 0, then I will add there. How we will add? 1 0 0 1 1 1. I'll get this. Okay, and if we do the XOR this with what our number was, our number was this, right? Then what I'll get? I'll get, if there are same, then we have 0, and if there are different, we'll have 1. So we'll get answer as our 2. So this way we have to find. So this is while adding, and this is for, let's say I'll use a Excel to explain in better way. Okay, to understand, first is how I will know which my least, okay, I want to find the least significant bit which has a 0 or which has a 1. For 1, to make it as a 0, when we let's say I will consider a is my number of set bits in string, in our num1 set bits. Okay, let's say I have a 3 and I have b is equal to 4. Okay, this is of num1 and this is of num2. I want to find the x, and to find the x such that x XOR num1 should be minimal, and number of set bits of num1, num2 and x should be same. Okay, so this you can see number of set bits of this num2 and num1. As we discuss num1, we can consider when we have the same set bit basically. Okay, because num1 XOR with num1, we will get the 0, which is a minimum. So we will minimize. Okay, we of course we will minimize this XOR, but for that we will consider num1 as our x and we will modify according to the our conditions. So let's say here a is less than b, right? And we can get one more condition, a is greater than b. Okay, if a is less than b, then I have to add that many bits. Okay, that many set bits. How many? Okay, we will what we will do is we will reduce. Okay, add set bit. Okay, and here what we will do is we will reduce. Okay, if we have a greater than b, we have to reduce. Okay, now, yeah, yeah. So here we have to add set bits and here we have to reduce. Okay, so how we will add is first we have to check. Next is check. We have to add. So we will check the least significant digit which has, okay, which has instead least significant I will I'll write as a LSD. Okay, consider which is 0 to make it 1, and here we have to check LSD which is 1 to make it as 0. Okay, now here how we will do this is to check least significant digit which is 0. We have to do first is first we first we have to do 1. Okay, let's say we will consider 1. We will left shift it by, let's say we have to check every time, right? So we can do with 1 2 3. We will do it till 32. Okay, because in integer we have 32 bits, right? So let's say I will do 3 or 2, and Okay, I will do this and with and operation with what? With our num1. If it is greater than 0, no, if it is equal to 0, because we want to find 0, right? If it is equal to 0, that means in at this index we have 0. That means from the right we can, let's say I will write this instead. Let's say 1 0 1 0 1. We have this, and we have 1 1 0 1 1 0. Okay, this also have 3, right? Why I will write one more one. Yeah, this is my num1 and this is my num2, where my num2 has greater. Okay, my a is less than b, so in that case I will find. So here I'll write 1. Okay, initially if I do the left shift of 1, I have this one, right? So let's say as we are considering 5, I'll write. Okay, so if I do this, this is 1 left shift by 0, that means 0 index. What I'll get? I'll get this one with, and with this one, and with this I'll get answer as 1, because this will be zeros. Okay, this will be zeros. Yeah, this will be 0. That what I'm saying is, I'll consider this one. 0 0 1, one more 0. We will do the and operation with what? With this 1 0 1 0 1 1 0 1 0 1. What I'll get is this 1 1 will get 1, and rest all will get 0, as these are 0. So I'll get answer as 0. Here we are checking with 0. Why? Because I want this number should be 0, then I'll get what? I'll get 0, because these here 4 are zeros and here 1. So we'll get, if we get this 0, that means here we have at this index 0. Okay, 0 bit, and we want that only. We want a 0 bit, okay, which is a least significant digit, which is a 0 bit, and we have to add that. So I will check this condition, and here for 1, that means at index 1. Okay, I'm just telling this is index 1. Okay, at position 1 you can say, at position 1 we have 0, so I'll get 0. So in that case what we will do, we got 0. Okay, so how we will make this 0 as 1? By doing the XOR, because we know if both are different. Okay, then okay, if we have 0 XOR 1, we will get 1 only. Okay, and if you have 0 XOR 0, we will get 0. 1 XOR 1, we will get 0. So what we will do is, our, let's say I will write answer. Okay, our answer we will do XOR with what? With this 1 left shift by I. Then I will get my digit. This, okay. If I do the answer left shift by this, I'll get this digit, and we will do the XOR. Okay. Now same case here. What we will check is 1 left shift by I and num2 num1, if it is greater than 0. That means here, let's say I want to check what? I want to check the set bit, and let's say here I will add 1, and I will check this with 1. I'll get 1. That means at the first position we have 1. And if I do this thing, here I'll write 0 1. Okay, that means what I'll get 0 0 1 0 0. Okay, some value. Then I can say this bit. Okay, this bit is a 1. So then what we will write is here same thing, because even though after doing the XOR uh, we will get 0 here, right? Because it is same. So we want to make this as 0. Consider this is also our 0. Okay, So in this way we have to do. Let's code it. So first is we want to count. So we will just do integer dot bit count. This is a method which will give us set bits. Okay, of what num1, and int b is equal to integer dot bit count num2, and our int answer is initially it is will be num1. Okay, we have to change in that only. For int I equal to 0, I less than we have 32 bits, and we have on two conditions. Okay, if my a is less than b, and if my a is greater than b. Okay, if my a is less than b, I have to add. So to we have to find lsd 0, and here what we have to do is reduce, find lsd as 1. Okay, now if I want to add, we have to check only not this condition also, and we will check what, we will check 1 left shift by I doing and with our num1, if it is, as we have to find the lsd, if it is equal to 0. And here what will be our condition, here it will be and 1 I and num1 if it is greater than 0. Okay, then here we will decrement a, here we will increment a. It will stop when a is equal to b, or you can say both the conditions fails. Okay, now the main thing we have to do, we have to do answer XOR with what, XOR with our 1 left shift by I, and here also we'll do the same thing, and at the end we have to return the answer. Let's run this. Okay, uh oh, wrong answer. Ah, yes. -1 we are getting, right? Okay, here we are adding. Okay, so here we are adding, right? So we have to do a plus plus here, and here we have to do the a minus minus. Let's run. As we are adding, so our size of this a will be, we have to increment, right? And here we have to decrement, so that it will not go in the next iteration, like next this conditions. Yeah, let's submit this code. So this is a bit manipulation question. Okay, so yeah, you can see our solution got accepted. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you so much.